The concept of the perfect plan is a comforting illusion, a necessary scaffolding built by logic and exhaustive preparation. It presumes the environment remains static, the variables contained, and the systems compliant. Yet the history of elite operational deployment, whether in the cold vacuum of space, the crushing depths of the ocean, or the razor edge of metropolitan intelligence, is littered with the ghosts of meticulous schedules abandoned the moment reality intervenes. These defining moments, when the foundation of the objective dissolves into high-stakes improvisation, reveal the true capacity for human resilience and adaptation. What follows are 5 distinct accounts, where the boundary between success and catastrophic failure was measured in the instantaneous decision to discard the original mission profile and pivot toward an immediate, often terrifying, new imperative. The chronicle begins in the silent, chilling embrace of high Earth orbit with Project Icarus. The mission was a crucial lunar transit maneuver designed with flawless mathematical symmetry, a demonstration of next-generation propulsion efficiency. Inside the primary command vessel, the atmosphere was one of serene, measured control. Sunlight streamed through the observation ports, reduced to a stark white brilliance that made the complex arrays of internal wiring and cooling conduits stand out sharply against the deep, absolute blackness outside. For 4 days, the trajectory had been perfection, a steady, almost imperceptible acceleration punctuated only by the rhythmic hum of the life support systems, circulating recycled air, cool and metallic. Technicians in Houston Mission Control watched the feed, their faces illuminated by the cold, green glow emanating from the stacked monitor consoles. The air in the control room was dry, slightly pressurized, and heavy with the scent of ozone and stale coffee. The voices of the controllers taut with calculated rhythmic urgency as they monitored thousands of data points that scrolled across their screens. The system failure, when it arrived, was not heralded by flashing sirens or violent tremors. It began instead with a subtle yet devastating electronic stutter, a quiet hiccup in the primary inertial guidance unit. A dedicated diagnostic screen in the vessel abruptly shifted from a calming, stable cyan to a pulsing, urgent crimson. Within moments, the peripheral subsystems began to cascade, reacting violently to the loss of core positional data. The ship itself, massive and built for stability, gave a fractional, unsettling yaw, a motion alien to its pre-programmed path. In Houston, the rhythmic click of keyboards ceased. The low murmur of constant communication dissolved into a terrifying silence, broken only by the sharp, strained voice of the flight director demanding status reports. The core problem was critical. The loss of orientation control had triggered a safety override that cut power to the main thrusters, leaving the vessel coasting, agonizingly off course, toward a potentially lethal trajectory that would either fling them too far into solar orbit or initiate an uncontrolled, fiery atmospheric re-entry weeks ahead of schedule. The objective instantly pivoted. The initial mission, a demonstration of precise, fuel-efficient transit, was now nullified. The new, immediate mandate was simply survival through trajectory correction. The flight engineers, normally focused on long-term efficiency models, were plunged into an improvisation nightmare. They had to bypass the primary guidance unit and initiate an emergency auxiliary burn using the volatile maneuvering thrusters, a procedure never intended for sustained trajectory changes. The challenge was immense. A fraction of a degree too sharp and they would burn up. A degree too shallow and they would miss the capture window entirely. They were calculating the agonizing trajectory change in real time, relying on visual star sightings and manual telemetry triangulation, a process dating back half a century, while bathed in the jarring, pulsating red emergency lighting that saturated the control deck. For nearly 90 minutes, the vessel was functionally blind. When the decision was made, the commander executed the complex manual sequence, feeling the harsh, uneven jolt of the auxiliary thrusters firing against the intended inertia. The cold calculation of the ground team meshed with the brute physical application of the crew. When the vessel's status display finally blinked back to amber, confirming a stabilized, though drastically altered, path back toward Earth, the air pressure in Houston seemed to deflate audibly. Project Icarus had failed its transit goal, but succeeded in defining adaptation under the chilling constraint of the silent, unforgiving void. The focus shifts now from the high, ethereal void of space to the crushing, absolute darkness of the ocean floor, thousands of meters below the surface. This was Operation Abyss, a deep-sea salvage effort targeting a research platform lost years prior. The objective was meticulous, forensic retrieval, securing data logs and core structural elements. The operation utilized highly advanced unmanned submersibles, their powerful halogen lamps cutting cones of blinding white light through the Archy water column, illuminating fine suspended silt that drifted like snow. The environment was characterized by intense pressure, water temperatures hovering just above freezing, and a silent. The environment was characterized by intense pressure, water temperatures hovering just above freezing, and a silence so profound it was almost physical. On the service support ship, the crew monitored the acoustic signatures, listening to the high-pitched sonar pings. On the service support ship, the crew monitored the acoustic signatures, listening to the high-pitched sonar pings and the rhythmic drone of the submersible motors. Working in shifts marked by the relentless, monotonous rocking of the hull. The complication arose deep within the target structure. The engineers had determined the structural integrity was compromised, but stable enough for phased retrieval. However, as the retrieval arm of the primary submersible locked onto a key ballast tank, the delicate balance was shattered. A massive tectonic shift in the undersea geography and instability they had not factored resulted in a sudden, violent settling of the structure. The sound transmitted back to the surface was a terrifying low-frequent groan, muffled by the immense volume of water, followed by a sharp, cracking retort. The pressure hull of the target structure buckled catastrophically, imploding in sections. Within that collapsing infrastructure were two specialized observation technicians who had been operating a secondary remote vehicle near the periphery, now trapped in a rapidly collapsing labyrinthine field of mangled metal. The original mission parameters vanished in that instant. Salvage was irrelevant. The priority shifted instantly and savagely to immediate survivor extraction. The crushing darkness of the ocean floor transformed from an obstacle to a hostile, ticking clock. The internal oxygen supply for the trapped technicians was viable for perhaps 6 hours, but the pressure stresses threatened to rupture their compromised compartment far sooner. The primary manned rescue submersibles, typically kept in reserve, were immediately deployed, but they could not approach the unstable wreck site directly. The new plan demanded a pivot from meticulous external recovery to dangerous, high-risk internal navigation. The pilots had to thread their massive rescue vehicle through narrow, submerged caverns and passages created by the catastrophic buckling. Relying almost entirely on advanced 3D sonar mapping, because the dense clouds of disturbed silt rendered visual navigation impossible. Inside the rescue submersible, the pilot and co-pilot worked in an environment saturated with the sound of the hull creaking under the extreme pressure, the cold radiating through the metal bulkheads. They maneuvered the delicate mechanical arms with astonishing precision, using bursts of water jet propulsion to clear debris. Every movement risked destabilizing the structure further, potentially collapsing the narrow passage ahead. The silt stirred by their approach hung in the water, a blinding, choking fog, visible only as an impenetrable white haze in the sub's spotlight beams. Their voices, relayed back to the support ship, were stripped of emotion, conveying only essential vectors and depth readings. After an agonizing 4 hours, they located the compartment, using high-frequency magnetic resonance to pierce the metal wreckage. The extraction itself was a brutal physical effort, securing the trapped personnel through a modified docking hatch in the face of immense pressure differentials. Operation Abyss taught the sharpest lesson in deep-sea command. In the face of structural failure, the complexity of planned retrieval must instantly yield to the simple, brute necessity of saving life from the dark, crushing void. The stage shifts again, moving from the pristine, inhospitable wilderness to the sensory overload of a bustling, rain-slicked metropolis, the setting for the Sentinel Protocol. This was an intelligence-gathering operation, requiring absolute stealth and prolonged, silent observation. The operative, highly trained and positioned in a carefully chosen high-rise vantage point, was surrounded by the noise and kinetic energy of the city. The relentless, wet slap of tires on the street below, the distant, muffled sirens, the neon signs reflecting their harsh, vibrant colors off the wet glass and pavement. The atmosphere was tight, airless, and charged with nervous anticipation. The operative's equipment was minimalist: a long-range thermal scanner, a microtelemetry unit, and a specialized photographic lens. Resting on a tripod, draped in heavy, light-absorbing cloth. The mission was predicated on invisibility, gathering crucial data over a 72-hour observation window. The plan dissolved in a fraction of a second, betrayed by a phenomenon as mundane as refraction. The operative shifted position slightly, adjusting the tripod's angle by a matter of centimeters. At that precise moment, a beam of sunlight, unpredictable and sharp, cutting suddenly through a momentary gap in the dense cloud cover, hit the highly polished metallic housing of the primary lens. Even though the lens itself was shielded, the flash of reflected light, microscopic in its duration, was enough. Down on the street, approximately 400 meters away, a counter-surveillance officer, a man trained for extreme vigilance, caught the unexpected glint. The operative's cover was instantly, definitively blown. The mission immediately morphed from silent, prolonged observation to high-speed, desperate extraction. The meticulous schedule of data collection was abandoned. Every microsecond was now critical. The operative's training took over, a primal, violent shift from stasis to explosive movement. The objective was no longer the acquisition of intelligence, but the retention of the operative, who held critical, non-transmitted data that could compromise the entire regional network. The primary extraction route, a slow, discreet exit through the building's service tunnels, was instantly deemed obsolete. The new route was vertical and chaotic. Discarding the observation equipment, the operative moved, the sudden weight of the tactical gear feeling heavy against the backdrop of the silence that suddenly enveloped the space after the initial panic. He burst out onto the rooftop access ladder, the air hitting him with a shock of cold, wind-driven rain. The escape sequence was a frantic, terrifying ballet across crowded rooftops, where every step was measured against the increasing proximity of the alerted counterforces. The visual details were intense. The sharp, gritty texture of the tar and gravel roof membrane underfoot, the slick, cold feel of wet metal railing against gloved hands. The distant, rising wail of sirens closing in from the narrow, echoing alleyways far below. He transitioned over a 6-foot gap between buildings. The brief, stomach-dropping moment of freefall focused entirely on the landing point. He utilized the city's inherent chaos, the snarl of traffic, the startled shouts of pedestrians, as immediate, temporary cover. The Sentinel Protocol concluded not with a delicate data transfer, but with a visceral, raw race against the clock. The very atmosphere of the bustling city leveraged as both an enemy and a crucial element of temporary escape, proving that in urban warfare, the fastest adaptation wins the second act of survival. Moving far from the concrete jungle, the fourth case study takes us into the desolate, wind-whipped expanse of the polar plateau, the Aurora Borealis expedition. The setting was profoundly isolating, dominated by the constant, stinging spray of ice crystals carried on the wind and the deep, pervasive silence of the ancient tundra. Above, the sky was often dominated by the surreal, silent dance of the aurora, sheets of green and white light rippling across the zenith, lending an eerie, shifting illumination to the vast whiteness below. The primary mission had been focused on deep ice core drilling, retrieving samples dating back hundreds of thousands of years to analyze atmospheric composition. The camp was a cluster of brightly colored reinforced tents surrounding the primary drilling platform, which constantly emitted a low, powerful chug as it pushed its heavy steel teeth deep into the frozen crust. The goal was stable, methodological science, extracting ordered history. The plan was derailed not by mechanical failure, but by unparalleled success, a seismic anomaly far exceeding their expectations. Deep within the Earth, over 100 miles from their meticulously planned drilling grid, the advanced subsurface monitors registered a sudden, intense resonance. It was not the predictable noise of glacial movement or tectonic settling. It was an unstable, highly energetic tremor pattern suggesting massive, rapid displacement within the Earth's mantle beneath the permafrost. The data streamed into the command tent, interrupting the routine monitoring of core stability. Dr. Elias Vance, the chief seismologist, watched the spectral analysis unfold. The wave patterns were singular, unstable, and suggested the presence of ancient, volatile gases trapped in a highly compromised subterranean pocket. The potential for a profound scientific breakthrough, understanding geological pressures underneath the tundra, was immense, but so was the immediate physical risk. The initial mission objective, the stable collection of historical ice data, was suddenly rendered secondary. The team immediately abandoned the primary drilling route. The vast frozen landscape was now viewed not as a static scientific resource, but as a rapidly changing, unstable matrix. The new imperative was to chase the unstable, seismic anomaly before the pressure either dissipated or triggered a major fissure across the landscape. This required trading the slow, methodological process of drilling for the rapid, high-risk deployment of light, mobile sensor arrays deep into the projected instability zone. The pivot was logistical chaos driven by scientific urgency. Heavy machinery was shut down. Fuel reserves were diverted. The focus shifted to light, fast-tracked vehicles and manual sensor placement. The team moved out across the unpredictable tundra, the crunch of their boots on the hard-packed, wind-scoured ice providing the only sound beneath the relentless howl of the wind. They were chasing a ghost, a vibrational signature that fluctuated wildly. The risk was constant. The instability zone was marked by hidden fissures and rapid melt channels caused by internal heat. The tension inside the lead vehicle was palpable, a mix of scientific elation and profound physical dread. The air inside the cabin was humid and warm, sharply contrasting with the -40-degree dry cold outside, the condensation fogging the thick glass windows. The team manually drilled and implanted the sensors, moving swiftly across terrain known to hide dangerous crevasse fields, following the auditory signal of the anomaly as it pulsed deeper into the frozen unknown. The Aurora Borealis expedition had fundamentally shifted its definition of scientific success, prioritizing the fleeting, dangerous opportunity of a seismic event over the stable accumulation of planned data. Our final account descends into a desperate race against physics and gravity, detailing the Keystone Maneuver, a catastrophic infrastructure response. The backdrop was a massive, aging hydroelectric dam, its concrete walls towering oppressively against a swollen, gray sky. Below, the river, engorged by unexpected seasonal rain, churned relentlessly against the reinforced structure. The mission, initiated days earlier, was scheduled dam reinforcement, a calculated application of specialized polymers and tension cables to stabilize the deteriorating concrete superstructure. The environment was deafening, dominated by the deep, visceral thrum of pent-up water pressure resonating through the concrete and the low, constant roar of the spillways channeling excess volume. Engineers moved across the structure, dwarfed by its scale, focused entirely on meticulous structural patching. The failure was abrupt and total. During a routine subsurface inspection, microfissures, minor leaks that had been the focus of the reinforcement efforts, began to spread with terrifying speed. Weeping water turned into surging jets, eroding the internal aggregate structure far faster than anticipated. The structural engineers, looking at the rapidly degrading stress measurements, understood the horrific truth. The pressure load was fundamentally untenable. Stabilization was now impossible. The kinetic energy behind the swollen reservoir was too immense, and the dam was failing at its core. Within 3 hours, the structure would rupture, unleashing a cataclysmic flash flood that would wipe out the downstream valley settlement, a community of thousands. The mission immediately transformed into a precise demolition procedure. The objective pivoted radically from saving the structure to guiding its inevitable failure safely. This was the Keystone Maneuver, a controlled, tactical breach intended to disperse the water volume over a designated, less populated floodplain, buying critical time for evacuation and mitigating the overall destruction. The challenge was immense, placing highly precise shaped charges on a stressed, vibrating, rapidly failing edifice. Any miscalculation in placement would result in a chaotic, ungoverned breach, precisely the scenario they were attempting to prevent. The specialized engineering response team moved with terrifying urgency. They ascended and descended the slick, cold, vibrating face of the dam, harnessed against the rising roar of the pent-up water. The sensory details were dominated by the noise, a high-decibel, sustained sonic assault that vibrated through bone and muscle. The texture of the concrete was wet, gritty, and alive with the subtle tremor of imminent failure. The engineers worked by instinct and decades of training, measuring distances not with leisurely tape measures, but with rapid-fire laser ranges, mapping out the strategic weaknesses that needed to be leveraged. They focused on placing the charges high on the flank, away from the deepest part of the reservoir, aiming to create a focused, directed V-shaped notch. The deployment took 76 frantic minutes. As the team raced back to the safety zone, the structural fatigue was visible. Large chunks of aggregate concrete were sloughing off the dam face, and the volume of escaping water had increased tenfold. The countdown was initiated. The sound of the detonation was not a single sharp crack, but a sustained, deafening thump, followed by the sickening, tearing sound of reinforced steel cables giving way. The resulting breach, though terrifying in its volume, was precise. The engineers watched the pent-up water surge through the targeted notch, rushing away from the downstream settlement and cascading into the prepared flood buffer zone. The Keystone Maneuver was not a success defined by preservation, but by the instantaneous, terrifying realization that the only way to save lives was through the controlled destruction of the very thing they were sent to protect. These 5 accounts, from the cold silence of space to the violent roar of a collapsing dam, illuminate the fragile and often invisible boundary between success and disaster. They are case studies in the instantaneous human capacity for radical, high-stakes adaptation. In each scenario, the failure was precipitated not by incompetence, but by the brutal intrusion of reality into the perfect model. The defining characteristic of these elite teams was the ability to recognize, without hesitation or regret, when the original objective had become utterly untenable. They demonstrate the complex mental shift required to discard sunk costs and institutional inertia, embracing the immediate, terrifying chaos as the new operational environment. The true measure of preparedness these missions attest lies not in the perfection of the plan, but in the rapid, resourceful capacity to write a new one when the first draft has been irrevocably shredded by circumstance.